All right, so in this lesson, we are going to learn how to write names from chemical formulas, specifically ternary ionic compound formulas. We're going to work through a few examples, and then we'll write up a set of how-to notes to capture the process that you do this. So our first example is going to be barium BaSO4. Okay. And so what you need to do here is, since we know everything in all ionic compounds are written cation first, anion second, we need to be able to name each parts of this. So Ba is the chemical formula for barium. And what we need to do is check to make sure that barium does not need a Roman numeral. So if we look at barium and we look in the upper right corner, there is only one possible charge. So that means we do not need to specify what charge this barium ion is. So in this case, we do not need a Roman numeral. So now all we need to do is name the second part of this substance, and SO4 is a polyatomic ion. So we're going to go find the name on reference table E. And so I spot SO4 right there, and it is called sulfate. So this is barium sulfate. Second example is going to be K2 Cr2O7. And we're going to take a look at the first part of this, and then we'll take a look at the second part of this. So we know that the name of this symbol is potassium. And we need to decide, does it need a Roman numeral? So we're going to look on the periodic table and see that potassium has only one possible charge. So potassium does not need a Roman numeral. And then we're going to look up on reference table E, Cr2O7. So when we look here, we find Cr2O7 right here, and it is called dichromate. So this is potassium dichromate. A third example is going to be MgCH3COO, close parentheses, subscript 2. So we're going to name the first part of this. Mg is magnesium. We're going to check to see if it needs a Roman numeral. With only one possible charge, magnesium does not need a Roman numeral. So now we just need to name the polyatomic ion here. So we're going to go to reference table E. We're going to look for CH3COO. And we find it right here, CH3COO. It is called acetate. So this is magnesium acetate. A fourth example here is FeNO3 in parentheses 3. So let's go ahead and name this first element. It is iron. We're going to go to the periodic table and we're going to find iron. And we're going to see that it can be either a +2 or a +3. So we do need to specify that charge, right? So the question is iron a +2 or is it a +3? Question mark, question mark, question mark. We need to figure that out. We don't know what that is just yet. So we're going to leave the parentheses open. We know we have to put a Roman numeral there. We'll come back to that. So let's take a look at what's inside the parentheses. I see NO3. Let's find out what that name of that is. So NO3 is right here. It is called nitrate. So this is iron nitrate. And the last thing we need to do here is figure out what the charge is and put a Roman numeral there. So here's what we're going to do. We have to do a little uncrisscrossing, right? So let's start with our nitrate. We know nitrate, NO3, is a -1 charge. So this whole thing is a -1 charge. But notice we needed 3 of these. So what that looks like is this. So there's 3 of them, totaling up to a total charge of -3. So this one iron has to be a +3. So because it's a +3 charge, we're going to put a Roman numeral 3 right there. That is the name of our compound right there. Okay, one other example here is going to be FeHCO3 in parentheses, followed by a 2. Okay, so we know Fe is iron. We're not sure yet if this iron is a +2 or a +3, so we'll come back to that. Now look up HCO3 on your reference table E. HCO3 is right here. It is called hydrogen carbonate. So iron, hydrogen carbonate. And to figure out what the charge here is, we have to do a little sleuthing. So HCO3, that whole thing, if you recall, HCO3 has a -1 charge. Okay, but there were 2 of them, so that's HCO3, they're showing you a second one right here. But notice there's 1 iron, so the 1 iron has to be a +2. So we know that this Roman numeral here is a Roman numeral 2, and there you have it. Okay, so now let's try to capture this process in a series of how-to notes. Okay, so a series of how-to notes. Okay, so how to write the name from formulas. The first thing that had to happen was that you had to be given a formula. Okay, so we're going to put the how-to notes here, and then over here we're going to run through an example. So if I give you this formula, CO C2O4, notice that this is a little o and this is a big O. So I'm giving you a formula. The next thing you have to do is you have to identify the names of the ions, of both ions, the cation and the anion. Okay, you may need to use the periodic table. You are likely to have to use reference table E, because I don't expect that you're going to have all these memorized. Okay, and so when you are doing this process, here's a couple things to remember. You will need to decide if the cation needs a Roman numeral. Should be capital Roman numeral. Okay. And if it does, it will need parentheses. Use parentheses if it does need a Roman numeral. So that's one thing you have to do. And then use reference table E to find the name of the anion. Okay, so let's go ahead and show an example here before we get too far down this. So identify the names of both ions. We may need to use reference tables, E and the periodic table. So in this case, if we go back up and look at this, right, so the name of CO is cobalt. Right, so we know that that's cobalt, but we got to go to our periodic table and see if cobalt has more than one possible charge, which it does. Cobalt can either be a +2 or a +3. So that means this cobalt is going to need a Roman numeral, but to figure it out, we're going to have to come back to that. Let's decide what the name of C2O4 is. C2O4, we're going to go to our reference table E. C2O4 is right here, C2O4. It is called oxalate. So this is cobalt oxalate. And now we have to, so we've decided that it needs a Roman numeral. We're using parentheses. We got to come back to figuring out what that is. And we found the name of the anion. Okay. So the next thing we need to do is crisscross to figure out the charge of the cation. Okay, so to do that, I'm going to rewrite the compound down here where it's right next to the instruction. So CO, C2O4. All right, so what we see here is that we have one cobalt, and if we put parentheses around the C2O4, we see that we have one of them, right? We recognize C2O4 as being, that is one ion, the whole thing, C2O4. The whole ion has a -2 charge, right? But there was one of them. So that means if we have one of these cobalts, that one cobalt has to match that charge over there. So we now see by uncrisscrossing, you know, had we actually uncrisscrossed, we would have seen a particular problem, right? If this is a 1 and this is 1, we would have seen that this is a -1 and we would have seen that this is a +1. But that should be a red flag right there for two reasons. We know oxalate has to be a -2, and we know that cobalt cannot be a +1. So when you uncrisscross, you do have to kind of inspect it and make sure that those charges actually work. So that is not a viable option, but all we needed to do was double it, and we see that we have a +2, -2. So what this means, the +2 charge means the Roman numeral, we now know it. Roman numeral is a 2. So we're going to go ahead and put that up into the name. And we now know that our compound is called cobalt-2 oxalate. All right, so at this point you have written the names of these compounds given a formula. All right, thanks for watching. We'll see you back in the classroom.